Okay, but what I do want you to know how to do is to do it without a graphing calculator, because that's what you're going to have to do on every college entrance exam and and things like that. I will impound them for this test, because this is when we're, okay, we ready?
Yes.
Yeah. Okay, so what do we do?
Yes.
What do we do here? If we want to organize your thinking here, we want to find all the extrema. Okay, the absolute extrema, the absolute maximum and absolute minimum could occur where, first of all? Okay, they could be at peaks or valleys, right? So relative maxima or relative minima, or they could also end up being endpoints. So we just need to check. Now, one thing we know here, what we've established, and we haven't talked about this in a little bit, what we established is that all of the relative extrema, whether they're smooth or sharp, they have to occur at critical numbers. Right? There's only certain places where they could exist. What constitutes a critical number of a function? Where could peaks or valleys occur exclusively? Only one kind of place they could happen, they could occur, at a critical number. What's happening at a critical number? It's related to the derivative.
Slope is the same as the...
Slope is the same as derivative, so either the derivative equals 0, which would be a horizontal tangent line, good, or what's the other one? The derivative is undefined. Where it's undefined, we could have a sharp corner, right? And a sharp corner could be a peak or a valley, right? So then when we want to find the critical numbers, we're looking for critical numbers. When we're looking for critical numbers, that's a first derivative issue. We've got to calculate f prime of x, and either one of two things is going to happen. We're going to find the places where f prime of x equals 0, or where f prime of x is undefined. Right? Okay, make sense? So those are the two, no, that's what we always do. Those are the two, that's where critical numbers occur. Those, we want to find the places on our interval where the first derivative either equals 0 or is undefined. And then we have to test them all. Those are the critical numbers. Okay? So let's do that.
What is the point? You have to do with anything?
There is no point.
That interval thing.
Well, the interval, we're finding the extreme values on that interval. Yeah.
No, I got it.
Okay, so derivative. So what's the derivative?
No, yeah.
Okay. 7/3 minus 1 minus 3/3 is 4/3. So that's it, right? That's our derivative. Okay, so then we want to ask the question, where on our interval, well, first of all, is that derivative undefined any place? Now, we got to think what this means. X to the 4/3, if we want to write that as a radical, what would that look like?
Cube root of
Okay, cube root of x
squared form.
to the 4th. Okay, so then, so a cube root, this takes us back a ways. You know, the last couple of years we've talked a lot about radicals, indices of radicals. If we have a cube root, are there any rules that apply to cube roots about negatives?
Take the even root of the negative.
Yeah.
You can't take an even root of a negative number. Is that an even root or an odd root?
It's an odd root, so it doesn't apply.
It's an odd root, so it doesn't apply. Right. So when we're talking about an odd root or an even root, the reason that this one is an odd root is because the denominator of the fractional exponent was odd, which is the same thing as saying the index of the radical was odd. Okay? The fact that the 4 on top is even, that's important, but in a different way. It has nothing to do with the radical. Okay? So, in other words, are there any places then where our derivative is undefined? There's only two things we have to watch out for. We can't take an even root of a negative number, which doesn't apply here because it's an odd root. And then what's the other one we always can't do? Divide by 0. But there's no x in the denominator anyplace, right? The x it's not on the bottom of a fraction, so that can't happen, right? So therefore, in both cases, we're completely in the clear. There's no place where we're going to get the first derivative undefined any place, let alone on our interval. Okay? So we could say then, if we want to be really mathematical about it, we could say f prime of x is everywhere defined. So it's not undefined any place. Now, what about the other species of critical number, where it's equal to 0? So if we want to set our first derivative equal to 0, where is that going to be the case? Yeah, the only way that x to any power could equal 0 is when x is 0, right? Now, we could go through the pain and suffering of isolating x, but it's not going to do any good. If we divide both sides, or multiply both sides by 3/7, I'm just going to get 0 still, right? And then to get the x by itself, I could cube both sides and take a plus or minus 4th root, but I'm dealing with a 0, right? So what difference does it make? 0 to any power other than 0 is 0, right? So this is going to only happen, this is true, when x equals 0. So that's our one and only critical number, right? So all we've got to do then is we just have to make our little table and we had, what did we go from -8 to, is that what it was?
Yeah.
-8 to +1, and 0 was our critical number.
Yep.
So we're just going to have a little race and see which one gets the highest value, and that's the global maximum, right? Or the absolute maximum, sorry. And whichever one gets the lowest value is the absolute minimum. And then if we want to know if this thing is a peak or a valley, we can tell just by what the y values are of these 2 points, can't we? So if we plug this stuff in, what do we get? If we plug these values back into the original function, x to the 7/3, what's -8
Is that, okay,
to the 7/3? How would I do that?
calculator?
No.
Yeah.
Well, you won't. I'm not going to get a calculator for that stuff.
What? Cube root.
Cube root of -8 is
2.
-2.
Okay.
Okay, to the 7th. Now, we can be tricky about this. To the 7th, well, if -8 is -2 cubed, then -2 cubed squared, right?
What? Our brains don't work like this.
Oh, yeah, they do. That's just, now I multiply exponents. That's the same thing as -2 to the 6th, right?
Yeah.
So that gives us -8 squared is 64, right? Times another -2 is -128. And or you just figure it out. I mean, you know that you're going to remember this. You know that
Do it.
that 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64. That's one you'll just always remember. So then one more beyond that would be 128. And because it's an odd power on top, it preserves the negative sign. An odd number of negatives multiplied together in a string, which is all power is, makes it negative. Yes.
Why do we have to find the x is -8?
Say it again.
So why do we have to find?
This is endpoints.
Well, I know, but why is that possible?
Because we want to compare. We're trying to figure out where the extrema are. We know that all the action is going to occur at those 3 points, right? We got the endpoints, and there's only one critical number, so that's potentially a peak or a valley. It doesn't have to be, but it's potentially a peak or a valley, right? So by plugging in values for y, we can tell exactly what's going on here. That didn't seem like that cleared it up. Does that make sense? The highest and lowest points could only occur at endpoints or at critical numbers. So we'll just compare the results.
Then fucking you.
I know.
Oh, okay.
You got it. So -8, then I'm going to get this was -128.
Yeah.
If I plug 0 into the original, I just get back 0. And if I plug 1 in, I get 7/3. So the biggest, here's the winner.
I got 1.
1 to the 7/3.
If I plug x equals 1 in,
Oh,
I'm
yeah.
sorry.
Yeah,
No, I don't. I get 1. I was looking at the wrong. I was looking at the derivative.
Yeah.
I just get 1. You're right. My mistake.
No, what happened?
And those really are just what we got there. Notice these are just ordered pairs, aren't they?
Yeah, they are. So it crosses the.
So if I did a little sketch of this, you can really see what's going on. This is. I've got a point at 0, 0. I've got a point at 1, 1. And I got a point at -8 and -128. So then this thing is doing something like this, isn't it?
It can be quite a bit further down, but yeah.
Right? So is there a relative maximum on this thing anyplace?
No.
No, there's not. This one was a false alarm. It was a critical number that didn't pan out as a peak or a valley. So the absolute maximum was here.
Wait, so why was the slope 0? If it's
Well, because I didn't draw this curve very well, but here, let me back up a little bit, I guess. So it's doing this. It's going from way down there, and it's going like this. So there is a horizontal tangent there. It's just not a valley or a peak. Okay. So here's our absolute max.
Oh,
Here's our absolute min. Endpoints, right? Make sense?
Yeah.
Okay. Good. Good. All right. Let's see. What else we got?
The next one's exactly like this.
Yeah, the rest of them are pretty similar. Okay, that one's a little strange. Is that the one you wanted to look at?
Oh, okay.
It's really not that big a deal. Let's maybe look at that one.
No, it doesn't have to. You can just take a screenshot of
All right. Okay, find the extreme values of this weird function on this interval from -3 to +3 inclusive. Now, the moral of the story with these.
Wait, what was the answer to the last part?
2 points.
Yeah, we had.
Oh, okay.
This was.
One's in red there.
That was the absolute minimum.
Oh,
Was
okay.
at -8.
I get it now.
Absolute max was at 1, and there was no relative minimum or maximum. No peak or valley.
Are we just supposed to with common?
Yeah.
I'm not sure how they wanted you to do
No,
that.
so is the first one, then once you get that right, then oh, okay.
Okay, so the extreme values. Now, when we're dealing with absolute value functions, we always want to rewrite them as piecewise functions.
Right.
Okay, so if f of x is the sum of these two absolute value functions, I don't mind spending a little time on this because these are always the oddballs in calculus. I mean, they don't really follow a rule. You got to just turn them into these piecewise functions. Once you've done it a few times, though, it's not that big a deal. So let's rewrite the absolute value of x minus 1 as a piecewise function. Right? That's going to be what? The absolute value of x minus 1 either equals x minus 1 or 1 minus x, right? It's opposite. Right. When does it equal x minus 1? When an absolute value function does nothing when the argument of the absolute value, meaning whatever's inside, is positive. Right? So when x minus 1 is greater than 0 is when that's going to happen, but we want to solve that for x. So that x minus 1 is greater than 0 when x is
Greater than 1.
there you go. And then, of course, this is just going to be less than 1. And then in between, when x is 1, it equals 0. Right? So we got that.
Yeah. When it has a take it up another 3.
So real quick, what's this one going to look like?
You wouldn't have Janet would know.
Okay, so when is the absolute value of x plus 2 equal to x plus 2? When x is
-2.
greater than -2. It equals 0 when x equals -2. And it is equal to its opposite when x is less than -2. Hey, shut up, guys. Listen, watch. I'm getting questions from some people that aren't. I'm going to be really upset if somebody's asking me questions and not paying full attention. Okay?
Yes, it's -2.
So what about this? Now what? If we want to add these things up, these piecewise functions, all we have to do is something like this. F of x equals. So now,
At 0, that's x equals -2.
that's -2.
Okay.
Wait, why is it negative x minus?
It's the opposite. It's -1 times that, right? An absolute value takes its absolute value of an argument is positive only when it. You see what I'm saying? You have to multiply it, this value by -1 to make it positive. Okay, so now we got to look at this thing on all these possible intervals. So what's the most extreme negative interval? Well, x is less than -2, right? So let's look at what's going on there. If we split this thing up into x is, I need to make that a bigger bracket, I think. So the most extreme negative interval is going to be when x is less than -2. Okay, moving up, then we're going to be stuck between -2 and let's see, -2 and +2, right? We got x equals -2. We got x is greater than. Yeah.
5 of x.
Five.
It looks like it's F5.
Oh, I gotcha. Yeah.
There you go, next.
There we go. So then we got x is going to be greater than -2 and less than 1, right? Because we run into another boundary of 1.
Right.
We've got x equals 1, or we've got x is greater than 1. There's all the possible ways we could have sliced and diced this sum, right? Because we've got these 3 separate regions that define, right, three separate subdomains that define the absolute value of x minus 1. We've got 3 separate regions or subdomains that define absolute value of x plus 2. So when I combine those, we potentially get 6 different places where things are going on.
Is there supposed to be something in between x and 1?
-2 is less than x. Less than.
Well, right there.
Is there supposed to be
So
something
between
like a greater than or equal or?
Less than.
Is it -2?
So it's just minus x.
Well, it says x is greater than -2 and less than. Oh, whoops! I'm sorry. Less than 1. There you go. I got you. I thought you were asking a different question. Okay, so what's going on down here?
No.
When x is less than -2, that puts us here.
That's a
Right.
horrible color.
True. And here. So I got the sum of those two things. I've got 1 minus x minus 2, which culminates in what answer? -2x minus 1. Right? Everybody see that? No, I'm adding. Our original function was just I'm adding these two piecewise functions up, right? So when x is less than -2, that puts me here in this part of this piecewise function and here on this one. Now when x equals -2, that puts me here and here. Right? Make sense? So I'm going to get 1 minus x. And when x is between -2 and 1, that puts me here and between negative 2 and positive 1 in there, right?
I'm just throwing this out
So
there.
you those two, yeah.
I'm really.
Like I speak to the whole class when we say we're confused.
I kind of get it.
Okay, let me back up a little bit. I got to back up a little bit.
I actually really understand all this.
colors.
It's not that complicated, really.
I get it.
You guys are all
I'm
fools.
just.
I get it.
What's going on
I
right
get
now.
it.
Okay, so
I know it's sad.
let me take this piece by piece. Is everybody okay with the fact that when I add these two piecewise functions up, I'm going to have these possible 5 different boundaries? I'm getting something happening when one is a boundary for this piecewise function. Okay. Negative 2 is the boundary for this one. So I've got all these ways I can be between. I can be less than negative 2. I can be between negative 2 and positive 1, right? I could be greater than positive 1, or I could be actually at the boundaries. Okay, so then if I want to know what's going on, I know how I can do this.
So are you just basically combining the two?
That's all I'm doing.
Oh, okay.
That's all I'm doing.
Why
So when we are here,
Because the equation is.
That's what it
adding
takes to.
together.
when x is less than negative 2, that tells us that the absolute value of x minus 1 is behaving like this, right? Because x values less than negative 2 are also obviously less than 1, aren't they? Right? So all values of x less than 1 create this behavior. Everyone stop talking, please. Create this behavior, right? So I'm going to get 1 minus x plus whatever the behavior is from the other piecewise function here. Well, when x is less than negative 2, the absolute value of x plus 2 behaves like that, right? So I'm just going to sum those two things. Negative 1 minus x plus negative x minus 2.
X equals 2 is 0.
Okay, good. X equals 2. Now, when x equals negative 2, sorry. When x equals negative 2, that's still less than 1, so we're still there, right? Okay? Right? Okay? And when x equals negative 2, that means that this absolute value has a value of 0.
Right.
Okay? Now, we're going to see that this is really kind of a ridiculous thing to say, that when x equals negative 2, our answer is negative 1 minus x. Well, I mean, if x is negative 2, what is that value?
This is 1 minus x.
I'm sorry, 1. You're right. 1. So if x is actually equal to negative 2, then what's the value of that function? It can only have one value. Positive 3. So that's, at this point right here, at x equals negative 2, the y value is 3. Right? Okay, when x is less than negative 2, it's following that linear behavior. Okay, now what about in between? Okay, so in between, right there, when x is pinched between negative 2 and 1, when x is greater than negative 2 and less than 1, on this function over here, doesn't that put us right there? Right? When x is greater than negative 2, the absolute value of x plus 2 is x plus 2. Okay, when x is greater than negative 2 and less than 1, it's still less than 1. So this absolute value still has that value, so I have to add those. Right? So I'm going to get 1, exactly.
3.
Or is that what it is?
Yeah.
3, yep. Okay, so in between, I'm going to get 3.
You just add the two.
Okay.
And that's because I'm adding this plus that.
Make the x plus x is 0.
Yeah, 1 minus x plus 2 is just 3. The x's cancel. Okay?
Oh, okay.
Right? Okay.
Can you use red next to it?
What's that?
Red. Next color, red.
Oh, was that 1? What was the answer?
No, it was 3.
3. Okay. Red next time? Sure.
I like the Notre Dame green though.
You like that?
No, true.
I kind of got the combination going on a little bit, don't I? I mean, it's close. Okay, so x equals 1. Let's see, we're going to be kind of, we'll move to red, but we'll that color for my light color. How's that? So when x is equal to 1, we're there, right?
That's equal to 1.
Right? If x equals 1, that means it's greater than negative 2, right?
Yeah.
Okay?
But it's
And then over here it's 0.
should be negative 1. So it's
Exactly. So we're going to get, so we can actually get a value. It's going to be x plus 2, which is what? 3.
Okay.
Okay? Right? And then last one. When x is greater than 1, well, it's greater than -2 also, right? So we get x plus 2 plus x minus 1, right? So I'm going to get 2x plus 1.
Like it's 16 days to be on.
Right.
Okay?
It's gonna be worth 0.00001 third grade.
It's a lot of stuff. Okay?
Shenanigans.
Shenanigans, absolutely. Okay, so then, so what about f prime of x? Well, that's really simple. If we're going to differentiate this piece by piece, the derivatives are simple. On the interval where x is greater than 1, what's the derivative? 2. Okay, on the interval when x is greater than -2 and less than 1, derivative of 3 is?
Whoa, 3.
Derivative of 3 is? I know, I'll go back.
0.
0. And then
Yeah, thanks.
when x is less than -2, the derivative is -2, right? Okay, here, now you answer that question for me. Why did I skip those points? So when x equals 1, what's the value of the derivative? No.
Wait, so what I got?
Oh, it's 1.
Good job.
No, I tried that. It's not 1 too.
0.
No. When x equals 1, the value of the function is 3, but you're missing something important here. It's undefined. How come? How come?
It comes out 1 equals 0.
Well, no, that's not what I'm talking about. There's nothing algebraic that's telling you that, but there's where are derivatives undefined? Well, they're undefined when there's vertical tangents or when there's discontinuous, but they're also undefined when we make a sudden change in slope, right? That's called a sharp corner. If I have a sudden transition, think about this now. If the derivative of the function is positive 2 everywhere, x is greater than 1, and it's equal to 0 on the interval where x is less than 1, right? Then at 1, we're making this sudden transition from... Right.
Yeah, it goes exactly like that.
Not really.
So it's going like this. It has a slope of 0, and then it has a slope of 2,
Does it cost?
right?
Yes, because
And that's a sharp corner. So it's undefined.
I like how he tells us so we can never get sick.
Okay, what about when x equals -2? Well, same thing, right? We're making a transition from 0 to -2, so it's undefined. Make sense? So we can see, because we've got these, we've got these sudden shifts in slope, that we don't have derivatives there. They're undefined, and therefore they're critical numbers.
Aren't those important though?
So they are important.
Now let's go back to our question. What was that?
So now we got to go back, clear back up to our original question. Find the extreme values. Okay, well, the extreme values, we can just make they're going to occur at critical numbers or endpoints. Well, the endpoints are at -3 and +3, right? So let me grab this guy. We'll go to the next page.
Do you need help yet?
Jesus, this problem is way too long.
Well, this is the way, math can be long or short, depending on
Worth it, though.
what the problem dictates. I mean,
That
it's
is always worth it. Always.
No. It's so irrelevant. It's so irrelevant.
I know.
100% zero.
So what are the values that we have to check? What goes in our table here?
2, 1, -2, -1.
Endpoints, which were
3 later.
-3 and +3. So we go from -3 up to +3, and then we had
-2.
critical numbers where we had undefined slope, which didn't that occur at the junctions, at the boundaries. So at 1 and at -2.
And here.
I got those.
Oh,
Yeah, why do you do like that?
Wait, why do we take the derivatives and then just use those?
Silly goose.
Okay, now we just need to know what are the values of the function there. Yeah.
Why do we take the derivatives?
Why do we take the derivatives? Because the derivatives are what told us that these were critical numbers.
Oh, so we did all that to find what
Yep.
else?
We did all that to find the places where the derivative was undefined.
Wait, wasn't the middle one
I wouldn't have known.
Say it again.
Would the middle one be critical too?
Okay, the middle. What about the middle one? The middle one. If I have a horizontal line, then every point on that line has a horizontal tangent. True. So technically, maybe we could check that too, because that's where the derivative has a value of 0. Good point.
Yeah.
Okay, so let's check that.
See?
If we plug those in at -3, we're going to get what? -5? Right? Matt, you get this?
Yeah.
Okay. What about at -2? At x equals -2, we get undefined. Oh no, what do we get for y? Sorry, -2, we got 3. At 0, we got 3. At 1, we got
0, where's 0?
Yeah, where's 0?
No, it's 0.
Oh,
right there. X equals 0 puts us on that interval. Right? F of 0, when I put if I pick an x value of 0, that puts me here.
Okay.
Right?
One
At
is 3.
1,
3.
we get 3, and at 3, we get. Did I do that backwards?
No,
-3 should have been here. I should have got. No, I did it right. At 3, we get 7.
Yeah.
Okay, so what are the winners? What's the absolute maximum? Yeah, right there. Right?
Yeah.
There's the winner. There's the other winner. Okay? And there is no peak or valley. So there are no relative extremes.
Unless you're, couldn't you have just done that without doing the derivatives?
How?
Yes.
Am I graphing it?
No, because that's not the derivative.
Right, those aren't the derivatives. Okay, once again, I know this is a long, it's a lot of stuff here,
Yeah.
but the purpose of the derivative was only to tell us to find the critical numbers.
Right.
Think back to our original strategy. When we're trying to find the absolute extrema on an interval, we're just going to compare the y values to the critical numbers and the endpoints. But we didn't know where the critical numbers were. We had to find them.
But those weren't even the ones that are highlighted, like the bottoms.
Okay, but we had to check these, right? We had to check x equals 1 and x equals -2. Because those were sharp corners. So theoretically,
Oh, yeah.
they could have been, it could have been a sharp peak like that. Or it could have been a sharp valley like that.
What was the absolute?
What's that?
Go back. Fluctuates.
To here?
Fluctuation equation. Function of
Thanks.
fluctuation.
Why is that?
Well, when
Okay.
it's such a small interval, couldn't you just test it like every point like we almost did right there?
Well, try every, yeah, you're right. Okay, I think the question is could we have done this a different way? Well, yeah, we could have.
Would it be easier or harder?
Better question, faster or slower?
Well, I'll tell you what, it would have been faster if you didn't know what to predict. But once you've done a couple absolute value functions like that, you're going to know, you're going to be able to zip through the math a lot quicker. Yes, ma'am.
Why is that one the absolute minimum? Didn't you just say?
Oh, whoops, hang on.
Yeah, that's
Right, so
No, that's nothing.
yeah, nothing.
Why?
Because 3 is below 5. Hey, I really, this talking is getting. I mean, I can't even hear myself think. So you gotta quiet down. Okay, makes sense.
absolute minimum.
And so, absolute minimum, there isn't really an absolute minimum. There are an infinite number of points. If we graph this thing, it just looks like this, doesn't it?
So how are you going to answer the question then?
Right. So there is an absolute maximum here, and the absolute minimum. There's a shared absolute minimum among all those points.
So the
So
So it's not a minimum.
So can we put that in as an answer?
No, I don't think that's.
So so we go back to the original problem. Where's the original problem?
Go back 3, baby.
Let's do this. So on this one, what are the extreme values?
There's only one.
Yeah, so what was it? It was positive 3, 7?
Yeah.
So 7 is the extreme value. Is that what they want us to put in? The y value? Oh, yeah, y value. Okay.
Fail. Do it all over
That's
again.
wrong. That's not good.
That was 7/3.
Oh my God.
Oh, okay, hang on. The extreme value. So they want this, okay, I don't like the way they do this. Remember, they want to have all the relative and absolute. Now they're saying, what did they say that was?
There's 3 parts remaining.
Okay.
Would we also 5?
Yeah. So
The extreme values are 3, and then I put 5. Is that right? I put 3 and...
Can we go back and check so we don't...
No, 5 and 7. 3 and 7.
Why 3?
Well,
Why 3?
why?
Hold up, stop.
There's
No.
3 threes, so it can...
Yeah.
There'd be 5.
Right, but the lowest value, I think what they're asking is, what's the lowest value the function takes? Yeah.
Right?
I don't think it's
Wrong. Oh.
Yeah.
Try 5 and 7.
5, yeah,
Yeah, try 5 and 7. We're just 5. You only have
It's
one more
about to give
chance.
you the
5,
answer.
So it wants the other endpoint in there too?
Can we put
I
3,
don't-
5,
I
7?
don't think that's right.
3, 5, 7. Yeah,
No,
there you go.
well,
Winning.
See, that's terrible. That's not what it is. Why is 5 an extreme value? It's not. What they're doing on here.
So we
That's-
put the
I don't-
wrong answer?
There's more
a
parts.
relative.
to this
I
question.
think
Okay,
they're
we'll
saying
do
there's a
it.
relative.
Shh, shh, shh,
You have
shh,
less
shh.
than a minute.
Okay, let me finish up. What they want you to do, what they're asking you to do here is essentially this. I know what they're doing. They want you to do this part. They want you to make this table essentially, where you're putting in what are the values we're checking. We're checking there, and there, right? Or there, and there, and there. Look at the y values. The y values we get back are 3 and 5 and 7. So they want to know what are the numbers we get back for y. And then the next question I presume is going to say, what's the absolute maximum? Well, the biggest of the 3 was 7. What's the absolute minimum?
There is.
Well, I mean, this is one of those where you say tomato, I say tomato. In my mind, it's a shared.
I think we should exempt that problem.
They're going to want 3. Bottom line, they're going to want 3.
So if we put in the wrong answer, but really it's the right answer, like when you showed us what we get wrong.
Even know what you're gonna.
Well, it's a homework, so you can just you can just try it again.
But I mean, like on the test, if this kind of question comes up.
I won't put that question on the test. On the test, I'll choose ones that I like. That makes sense, Daniel. That makes sense. Good.
No, you all
Good.
put that one on Thursday. So
Okay. Good. Good.
Sure, if we didn't get to number 5, I don't understand.
Well, we'll have to do that one out of class. I got to move on to some different stuff today.
Here's my book.
Oh. Okay.
Please come to the office.
I'm gonna miss you.
I'm still gonna be here in there probably almost every day.
Okay.
Not today.
Okay.
Did
Good.
you ever find that book?
No, I haven't. But I honestly, the last week was so hectic. I didn't even look. I'll look this week though.
Okay, so should I not pay for it yet? And
Don't
just
pay for it yet.
wait to
Yeah,
see?
don't pay for it.
Audrey,
Don't pay for it.
Howard to the office, please. Audrey, ship